Hello everyone, welcome back to our series of data science with Python. So we will cover two essential concepts in our today's video of data science as in estimation model evaluation and stepwise regression. So first let's talk about estimation model evaluation. This is a critical step to assess how well your model performs on unseen data. We'll demonstrate this using linear regression and a dataset. So we will import our important libraries and load the data. So this is the libraries NumPy, Panda, sklearn model, learn matrix. These are data in terms of x and y, which is containing randoms. So we have created a simple data set and split it into training and testing sets. This ensures our model is evaluated on unseen data. Let's train a linear regression model. So this will be the code for train. Model equals to linear regression. Model dot fit equals to x train, comma y train, and y prediction equals to model dot predict x test. So using linear regression from SCIKIT underscore learn slash learn, we have trained a model and made predictions on the test set. So let's evaluate the model. For this, we will write the code about evaluation. This is model evaluation. This mean squared error R2 equals to R2 square y test over y prediction. F mean squared error equals to this and R squared score equals to this. So this will be our code. Let's run this code. First importing the libraries, then creating the data set and training it, then training the model and predictions, then model evaluation, and then printing our outputs MSC and R2. So here is the output mean squared error equals to 211.0.2539812 something something. R squared score equals to minus 0.404144 something something. So this is our output. The mean squared error tells us how far our predictions are from the true values, and the R squared score shows how well the model fits. In practice, lower MSC and higher R square indicates a better model. So our second part is demonstrate stepwise regression. Stepwise regression helps in selecting the most relevant features for a regression model. We will use a data set with multiple features to demonstrate this. Let's import the libraries. Here are the libraries. These are the libraries that we will import. So we have generated a synthetic data set with 10 features. Now let's apply stepwise regression using scikit-learn's sequential feature selector. Let's perform stepwise regression. This will be a code for that. Model equals to linear regression. This case equals to sequential feature selector. Model and features to select equals to 5. Direction equals to forward. SFS dot fit x comma y. Selected features equals to SFS dot get support. Indices equals to true. Selected features equals selected features. So here we are using forward selection, where features are added step by step to optimize the model. A sequential feature selector gives us the most relevant features. Let's evaluate the model with selected features. After selecting the top features, we retrain the model and evaluate it. You will notice an improvement in performance if irrelevant features are previously hurting the model. Let's check this code. Here we wrote the libraries that we will need. Let's import these. Then we will generate the data, synthetic data, then linear regression model, and stepwise regression, then sequential feature selector model, getting the selected features. Selected features equals to sfet dot get support and dash equals to true, and we will print it now. So it is 34569. Now we will train the model. Now let's train the model and run this whole code in a single go. So the model MSC with selected feature equals to 4197.05 something, and R square with selected features equals to 0.929 7741 something. So after selecting the top features, and that's it for today. We have covered how to evaluate estimation models and perform stepwise regression in Python. These techniques are incredibly useful for model selection and optimization. If you find this helpful, give it thumbs up. Thanks for watching.